welcome to the cross product. The cross product of two vectors in R3 is another vector, and this is the formula, and it's going to take us a minute to get there. So let's just start with the determinant of a 2 by 2 matrix. So that's up here. What we do is we take the product of the entries on the main diagonal and then subtract the product of the entries on the non-main diagonal. So for example, if I have this matrix here and I want the determinant, those straight bars read determinant. This is 4 minus -3, which is 7. All right, now suppose we have two vectors in R3 and we want to cross them. So here's the notation. Straight bars, you put I, J, K, top row, U, second row, V, third row. Then you're going to get 3 subdeterminants. The first one is determined by crossing out first column, first row of that matrix, and the numbers that are left are right here, and you take that determinant. Then the second entry of the answer is formed by crossing out first row, second column, and then you look at the numbers left, and you take that subdeterminant. And then similarly, the last component is found by crossing out first row, last column. Notice that the middle entry is negative. You'll learn more about why that is if you take linear algebra. So remember, dot product yields a scalar or a number, same thing, and cross product yields a vector. Okay, so let's just do an example. I think that's the easiest way to do this. Don't memorize that formula in the box, just memorize the process. So if I want U cross V here, I go straight bars, I, J, K. I put U in on the second row and V in on the third row. Okay, now I'm going to write down an optional step. When I cross out first row, first column of that matrix, I'm left with the subdeterminant 0, 5, -3, -2. Then the second entry is going to be negative. Cross out first row, second column, and write down the numbers that are left, 3, 5, 2, -2. And finally, for the last entry, cross out first row, last column. The numbers that are left are 3, 0, 2, and -3. Now this step is optional. You can write it down. It's especially good in the beginning to do that, but if you can do that in your head, I'm fine with that. So that gives us, now we take these 3 determinants and we get, for the first one, +15. For the second one, I get -6 minus 10, so that's -16. But then there's a negative out front, so I get 16. And then the last entry is -9. Okay, pause the video and try V cross U. Okay, hopefully you did that. If you didn't get the answer that I have here, -15, -16, 9, then pause the video and take a look at my steps. Notice that this is the negative of the vector we got above. And that's not a coincidence. Okay, V cross V is I, J, K, and I do want to see that, 2, -3, -2, 2, -3, -2. Straight bars over the whole thing. And that's, I'm going to skip the optional step. We can see if we take each subdeterminant, we're going to get 0, 0, 0. So V cross V is the 0 vector. Again, not a coincidence. And finally, U cross V dot U. All right, U cross V, we computed above. That's A. So 15, 16, -9. And I'm going to dot with U, which is 305. So now I'm going to get a number. And the number I'm going to get is 45 minus 45, which is 0. Again, not a coincidence. So we'll talk about properties of cross in a minute, but first I just want to show you a shortcut way to get crosses involving the standard unit vectors. So if you look at this circle here, and the arrows indicate which way you're going to cross and get positive. So for example, if I take I cross J, I look on my circle here, and I go from I to J, and this gives me K. If I go J cross I, then I want to go in the opposite way, and that gives me -K. And finally, J cross K, I'm going positive, that's going to give me I. Okay, properties of cross. C is a scalar, and U and V and W are vectors in R3. C, U cross V, is the same as C, U cross V, which is the same as U cross CV. So the C can go with the U, the V, or outside. Is there a similar property for dot? You should pause the video and try and fill in the similar properties of dot. Yes, there is. C U dot V is CU dot V or U dot CV. All right, U cross V is negative V cross U. So cross is anti-commutative. Dot is commutative. U dot V is V dot U. All right, distributive property. We can distribute this U to the V and the W. So this is U cross V plus U cross W. Yes, there's a similar property for dot. U dot V plus W is U dot V plus U dot W. Okay, so now number 4, take a look at the difference between number 3 and number 4. The only difference is now I'm crossing on the right, and I have to do that because cross is not commutative. So you need a separate property for crossing on this side. And the property is, this is V cross U, just keep the order straight, plus W cross U. Now for dot, this property is not needed. Dot's commutative, so if I dot V plus W with U on the right, I'm just going to get the same thing as I got in property 3. All right, V cross V is the 0 vector. The similar property for dot is U dot U is the length of U squared. So very different there. And then 0 cross U. First of all, that's got to be the 0 vector because you can only cross vectors in R3. So 0 cross U, and that is the 0 vector. And we have a similar dot property. If I take the 0 vector and I dot it with U, I get 0, the scalar. Okay, the interesting thing, well, one interesting thing about cross is that it's not associative, meaning if you take 3 crosses in a row, the order in which you cross matters. So here's an example with just the standard unit vectors. I cross J. If I do the first i's first, I cross I, that's 0. 0 cross J is the 0 vector. But if I do the I cross J first, I get K, and I cross K is negative J. And those are different answers. All right, so we're going to do an example that uses a lot of the properties above. I've got 2 vectors, U and V, and the only thing I know about them is that U cross V is this vector. And now I want to find this expression right here. So what I'm going to do is rename the first vector W, and I'm going to distribute by property. So this is by property number 3. I can distribute W to U, and I can distribute it to 2V. So now let's write out what W is again. That's U minus 3V. And I'm crossing with U, and then I'm adding on U minus 3V, and I'm crossing with 2V. Now I can use property number 4 and cross on the right side. And I can also pull out scalars. So if I start on the left here, I'm going to get U cross U, parentheses, then minus 3, I'll pull out the minus 3, V cross U, plus, now again, I'll distribute the 2V, that'll give me, I'll pull out the 2, so 2 U cross V minus 6 V cross V. Okay, U cross U is the 0 vector. V cross U, I'd like to write everything in terms of U cross V. So I can write this as positive 3 U cross V, and then plus 2 U cross V, and then minus 6 times the 0 vector is the 0 vector. So all in all, I've got 5 U cross V. And I know what U cross V is because it's written down above, 0, negative 1, 1. And so my final answer is 0, negative 5, 5. Okay, and finally, let's talk about geometric properties of cross product. Suppose U and V are 2 vectors in R3, and theta is the angle between them. Number 1, U cross V is orthogonal to both U and V, and that's a really important one. So that means U cross V dot U is going to be 0, and U cross V dot V is going to be 0. And actually, we saw an example of this first one on the first page. Second property, the length of U cross V is the area of the parallelogram spanned by U and V. And we're going to use that in an example below. And then finally, u cross v is the zero vector if and only if u and v are parallel. So now we have a test for perpendicular and parallel. The test for perpendicular is if u dot v is 0, and the test for parallel is if u cross v is the zero vector. So now let's do an example that uses property 2. We've got 3 points in the plane, and we want to find the area of the triangle determined by those 3 points. And so what we're going to do is look at the vector PQ and the vector PR and take the parallelogram spanned by PQ and PR. The area of the triangle will be half that area. So I've already started out. I've determined what PQ and what PR is, and make sure you pause the video and double check. I did the quit making poop formula. And now what I want, the area is going to be 1/2 the magnitude of PQ cross PR. So first I need to start by finding PQ cross PR. That's equal to straight bar IJK, put PQ in on the second row and PR in on the last row, okay? And you should probably pause the video and try this on your own. You should get 2, +3, +1. So the length of PQ cross PR is the square root of 4 + 9 + 1, which is the square root of 14. So for part A, the area, which we'll call A, is 1/2 of that. So 1/2 root 14. All right, and then there's a second part, B, find a unit vector normal to the plane spanned by P, Q, and R. So normal means perpendicular. I've got a plane containing P, Q, and PR. I want a perpendicular that points up like this. We'll call it N. The vector I want is PQ cross PR because that's perpendicular to PQ and it's perpendicular to PR. But I want it to be a unit vector, so I want to divide out by its length. So I want N equal to PQ cross PR divided by its length. Okay, well, I've computed all those quantities. The length of PQ cross PR is root 14. So I've got a 1 over root 14, and then PQ cross PR is the vector 2, 3, 1. And then you could distribute if you want. I'm going to leave it like that. Okay, and then there's a little bit about torque that you can read on your own, and that is the end of this section.